But you need to share the other screen with me, Ben.
We are live. Wait a second.
Okay, now I see what you are.
All right. Hello, welcome, Nico. Welcome to the webinar.
Hello. Hello, Rashbir. How are you?
I'm good. How are you doing?
Fine.
You're working from home today?
Yeah, we had some issues with the internet, so I had to do the webinar from home. Yeah, sometimes happens. Yeah.
Okay, cool. So what we're gonna talk
we
about
have,
is components.
Yeah, it's been many times that we've been asked about how Simumatik works and the components that we have created so far. That many customers, all our customers in the industry, they like that they can build components and they work realistically and they are connected like in reality and so on.
Right.
But we have had some questions mostly from education. Can we do simpler stuff? Can we do some components that doesn't need to represent the reality 100%, just to play around with PLC programming and so on? Okay. So we decided to go ahead and make an initial library of components that allow us to just drag and drop them into a workspace, connect them directly to the PLC, so you don't need to focus on drawings, connecting, using intermediate components like relays and so on. Okay. So it's just quite easy to get started, mainly with programming, okay, the programming part. Right. So the idea is to explain, maybe compare a little bit how we work, usually with Simumatik and the component-based approach, where the components have a symbol, and then you can build, you can reproduce the reality in Simumatik using the 2D diagrams and so on, very quickly, just with an example. And then we can show the difference. Yeah, we can show the difference with these new components. Yeah.
Okay. So this is how our components look like, which we already created before. And first I will show you that, and then I can show how we simplified these components. So let's talk about this conveyor in a moment. So previously how we were doing it, this conveyor has a motor axis. So this conveyor needs a motor connection to work. So here you can see that the motor which is connected is a DC motor here. So in the end, when we run the DC motor, then it runs the conveyor. That was the concept before. This is how technically we do it. We connect all this motor with the conveyor in a realistic way. And if you see at the diagram, you can also see the representation of this conveyor, which is, I think it's not here, but here you can see the DC motor. So we have to energize the motor with 24 or 0 if it's 0 volts, or AC if it's an AC motor. And then we can move the conveyor. Now the new concept is we don't have to connect the motor. We just connect power or the voltage directly to the conveyor. And we can also control the speed, right? I think I also noticed that in the mechanism.
Yeah.
Control the speed.
Yeah. So in reality, maybe sometimes you can hide our cameras if you want to show the right panels. But so in reality, if you want to run a conveyor with different speed, you need to use motor contactor, and you could, with 3-phase motors, you can run a star, a triangle, and so on. But usually you add a frequency inverter. So you have the PLC, then you have some securities relays or contactors, then you have the frequency inverter, and then you have the motor, and then you have the mechanical conveyor. So it's kind of a chain. Okay. As we will see now, the new components can be connected directly to the PLC. There is no need of contactors, frequency inverters, and so on. And using analog, as you were mentioning, using analog signals, we can we can control the speed directly. You don't do that in reality because you don't connect an analog output in a PLC directly to the conveyor. There is no such a connection. You do it through a frequency inverter or whatever. But yeah.
Okay. So
but in this case, we can show.
Is it fair to say that these conveyors has a built-in VFD now? Because you can control the feed, you can get the feedback, something like that.
It's
Something like
some
that.
kind of thing. Yeah. It's a package which includes everything to run it.
Okay.
It doesn't represent the reality, but the purpose of this library is not to represent the reality. It's just to give an option to quickly be able to build something and just program it. Yeah.
Okay.
I see you moving the cameras. Yeah. Good.
Yeah, I thought it's good to have you here.
Yeah.
Let's
So,
talk about our
yeah.
first component then. This is a new conveyor which we have built. And for the audience, this conveyor you can find in the factory components. So if we go to components and library, so you might see on the left side, you have your own library. You could go to public library because I'm in the Simumatik organization. So in public library, you will find factory components. And these are the components on the left side. And you can see some of the components are published, so you can use it right away. And some of the components we are working on and going to publish in the next days. So you can stay tuned.
And then there may be more components that we will be adding. And the idea with this library is that we get some feedback and so on. If people like this concept as well, we can add more components. So this is just the initial draft, but we wanted to present the library in this webinar and see what people think and get some feedback and so on. Yeah.
Okay, so let's see if you want to know more about the component. You can always click on that and click on open. And all the magic which our developer has done is in the editor. How this component behaves, what are the parameters, you can always go inside and see. And if you want to make more changes, go ahead, clone it, and do your own scripts and define the behavior yourself. So it's always open. You can use our components the way you want. You can replicate that or add more functionality. This you can always do. And if you are following the course component builder or component creator, you will find how to use the scripts to modify the behavior. So in this course, you will see step-by-step approach to make a component. And assets you can also...
Yeah, I will... Maybe one thing just to mention that something that we have also done with these components is that in order to make it even easier, as you will show later, to test the system when you prepare it, we have added two features. One, you can force the components by hand by clicking on them during the emulation. Yeah, so this is something that we have done in some components, in some projects, just because we think it can be useful for testing and so on, but all these components in this library, they have this feature. And it's something that, as you were showing, is built in the behavior. So if someone is interested, how did they do to allow the user by clicking to force the moment and so on, using the user action. We have all the components with that. And in addition to that, or to support that, we also change the color or parts of the components, so you know when they are forced, and so you will show it soon. But I was just telling that we have done, we have added some extra features, so visually you can understand better what's going on, and you can also interact with the components.
Right, this I want to show you live now. So for example, I was working yesterday and I put some components on the workspace just to make a demo system. So what you see here is a chain conveyor, and it has a box on that. And I have my box entry coming somewhere here. So like Mikkel said, you can interact with the components. In this case, if I click on my conveyor, you can see an arrow, and this shows that conveyor is running. So you don't have to connect the PLC or the power supply to test it. You can directly test it by clicking on it once. And if you click again, it will change the direction. So one click in one direction, second click stop, and third click another direction. So I think this is the very easiest way to test the component and then make a logic later on. So similarly, if
that works for conveyors, but also for other components like you have.
For other components. For example, here we have a turntable. So if I click once, it will go the other direction, but I want it here. So let's bring it here. And then I stop it. And now this turntable has to rotate. So here I have connected a switch to show you that how you can also control it using your electrical power. So if I click on that, it will rotate. And now you have another option to break it on right side or left side. So let's take it in one direction. So I move it in this direction. And then we have a curved conveyor, which can also be triggered by clicking on it. So if I click on that, it goes in another direction, and then it goes here. And then
for example, the core doesn't have an arrow, or maybe something that we need to add.
Yeah, this we need to add.
We can add that, yeah.
Yeah, space, something we can add. And then here is an exit point, the box will go. So this is something very easy to make some trials. I believe that was the main reason to create this component. And now if you see that the turntable is not ready, you can use a stopper, which will stop the box from going outside. So you can make some kind of PLC logics to find out the position of your turntable and then find out if it's ready to load or not. Based on that, you can control your stopper. Now you can see that because of physics, the stopper was on. And this is hitting the stopper, so I have to maybe bring it down. Okay. So
oh, nice. Maybe we can check one of the components, the conveyor, to see the interface, which are the signals. Not the physics, but the interface to the inputs and outputs and so on. Take a simple one, maybe the conveyor, the first conveyor you have there.
Somewhere else, so maybe you can come here for that. Okay, so now we can use for the simple one, this conveyor. So on the right side, you can see the gear ratio, and the gear ratio defines the speed of your conveyor. So you can play around with the gear ratio however you like. And then you have analog range. Okay, let me just open this in the description. There we have some description. So anytime you can go to component page, and there you can find the description of the variables. So it has two ways to control. One is digital, another is analog. And this can be controlled using what you enter in the config. If you enter 0, which is by default, it will act as a digital conveyor. Basically, it needs just on-off signal, 24 volt or 0 volt. If we configure it as 1, it will take analog values, which can be used to control the direction or the speed of the conveyor. So interestingly, if you have PLC in your Simumatik and you have digital IOs, you can use it as digital signals for 0. If you want to control the speed dynamically, you can use 1, and then you have to provide 0 to 10 volts from PLC to control the speed of conveyor. So this is the difference between 0 and 1 here. And furthermore, if you want to add some more information, you can always go to editor, add some more variables, connectors, whatsoever you like. And then you will find this signals here. So you have voltage range by default, -10 to +10, conveyor speed is 0 at the moment, configuration is 0 by default, analog range, this is coming. Is it a feedback or is it coming from the...
I think it is, because if we check the inputs and outputs, we have, let me check, we have one...
range.
We have the analog...
Okay.
But we have the analog speed. We have the analog speed as an input. So I guess when you want to run in analog mode, you use the analog speed input port, and then it will work with the voltage range.
Right. Okay. And here you can see on the bottom right, you have
those are
analog input, and this is digital inputs, 24 and 0 volt. Yeah. So this is how you can control the conveyor. I do not have, I have a panel here. So inside this panel, I have a PLC. So you can see here, I have a PLC. So if I want to connect this conveyor with the PLC, it's actually very easy. You can check the PLC IOs. Here, inputs and outputs, and now if I need to link my conveyor, I go here. So the first one, if you click hover your mouse is clockwise, so you can select, you can here go to your PLC and connect output 0.
Take an output,
So we don't need to connect any motor. We don't need to connect any live and neutral to the motor, directly to the PLC, and we'll control the direction.
Yeah.
Cool. So this was
Yeah,
like
so that simplifies quite a lot the process of building, connecting, and so on. Again, it adds some limitations because you cannot validate that you have done your design is well done and so on. But if you just want to focus on the programming part, we see a potential. So let's see what the user says to this library.
Maybe I can show some more components that we have in this space. So here I have another conveyor, and this you can also control, but here you can see it's all green. So it's just visually you can see from far behind which conveyor is running. So that was the idea. So this is similar to the other conveyor. The difference is it has it's not a chain conveyor. It's like a normal belt conveyor. And here we have some pushers. And these pushers has physics inside. These are used to push the boxes. So my intention was to make some sorting logic, but I didn't do that. But this is something users can try themselves. Based on if the box is small or large, you can always push them on the sliding conveyor. This also has a physics, so you have a nice flow of boxes. Similarly, you can also do that on the next one as well. And this is happening.
And the interaction is the same. Because you click once, it goes forward, you click another time, it goes back.
And if we look at these pushers, we can also show you they have some signals. It must be right conveyors. So you also have some variables. It can also be converted to analog pushers, I believe, where you can put the set position and you can see the velocity and voltage range is always there. And here you can see if the limit switches, for example.
Now my camera is on top of the panel, so you know.
Sorry about that. So here you can see on the bottom, it says back limit 24 because it's retracted. So you have a feedback coming from the pusher, which tells you it is retracted. So if I extend it now, I think it's the other one, this one. Now you can see that front limit is 24 volt and back limit is 0. So you have a kind of like a feedback coming from the pusher, which you can use to make a sequence for your PLC logic. Yeah, it's like they have built-in sensors. That's also something that when we work with other components that we have created previously, you need to add the sensors, position them, feed the sensors with power supply all the way, like in reality. Here, we just keep it simple. The cylinders or the pushers, they have everything, the pneumatic valve. We could say that they include the pneumatic valve, the compressor, the sensors, and everything. So you can just use the PLC input and outputs and connect it directly. That's right. I think I remember when I made one system on electro-pneumatics or hydraulics or electro-pneumatics, I was controlling the speed using flow control valve. Here it's already inside. You can maybe check the velocity and you can change the speed of the cylinder as well. I think it's
exactly.
In script you can also do that.
And we could check the documentation or the description of the component. Maybe there is an analog version where you can control it. I don't know. I haven't actually checked, but there is.
Oh yeah, there is an analog. So we can control.
You can set the position.
That's cool.
So you can send the position to the pusher and also get the actual position.
That's nice. A nice feature.
And so there are 4 configurations.
Okay. So here, do we get the position feedback as well? I was wondering that position. No, not yet. Okay, this is something we can check again. Because in analog mode, once you give the position, I'm sure there is a way to get the feedback as well to control if it has reached or not. Kind of like analog control. Okay, so this was like few components that we have created, but we already, like mentioned before, we have more components which are...
Yeah, we can take a look to what we have.
Yeah, I can show you something. So for example, we have a belt conveyor, which is 4 meters long. So the one which I'm using is, I think, 2 meters. So you can also use 4 meters. And then you have belt conveyor 6 meters long. So the functionality...
So we have 3 sizes.
Just the length, yeah, 3 sizes. And then we have some factory product. So just a blue product, which actually we use in, I think, robotic cell, which I haven't shown you.
Yeah.
Because we use this robotic cell. If you check our last webinar, it was on OpenCV.
Yeah.
No, not OpenCV, with the factory with Python. There we have used this factory cell, and we can see how this is functioning. And then we have some sensors. This is a capacitive sensor, just giving you on and off signal, digital sensor. And this is very interesting, factory chain transfer. So basically this is under production right now. It is basically moving the product left and right. So transferring from one conveyor to another conveyor, which is also you can use. Very interesting one. I'm curious how this is gonna come up in the end. Then curve conveyor we have already seen. Factory floor I'm already using, just to have a plain base in our factory. Green product, similar to the blue one, just a difference in color. Factory guide, this could be interesting. This is to align your products on the conveyor in a better way. You can use this alignment thing. Sometimes it's quite interesting. Then we have a factory photoelectric sensor, which is just telling you if the object is there or not. I think it's also giving you analog output to tell you how far is the object. This kind of look like the look and feel is from a manufacturer. I'm not sure. Apple.
Yes.
Looks like that.
Yeah.
And then interesting one is coming, pick and place, which could be used for...
Yeah, this is like an arm, like a 3 axis arm. Yeah.
Are we trying to make this use motors? I think it's motorized, right? So you can control the position.
Yeah, but I think again it will have a digital mode and an analog mode, so you can just move back and forth, and there will be some limit switches, and then you will be able to control position, I guess, but very easily, directly with digital inputs and outputs from the PLC. No need of axis and so on. Yeah.
Okay. Pivot arm we already have published. I did not use it, but this is used again to move the components from one place to another. Also very interesting.
Like the pusher, but
different. This is also an interesting one. It's a pop-up wheel sorter. I can maybe bring it. I can also show you later on. So basically, it is moving left and right to move the boxes in different directions based on, again, you need to do some sorting. You can either do sorting by height or by weight, and you can move the components wherever you like.
Type of product or
This we have already used. It's just a slide to slide down the component. And factory stopper, I have already used it, a different version of that, but this is also used to stop the components running on the conveyor. Turntable.
Yeah, that's a static one, or I will say that's the static one, and then you have a movable one.
Oh, okay, this is a static one.
I think so,
Yeah, this is just a static one. And then we have a turntable, which I already used to turn the table and move the boxes left and right. This was one of the production cell, and this is quite interesting. Maybe Mikkel can tell you more about it. What was the idea? Was it like a custom project, or what was the idea?
Yeah, no, the idea was to be able to add a process to the factory, without requiring to program an entire machine. So this is a kind of a smart component that you can feed with products. They need to be these factory products, but if you feed them with products, adding a conveyor before and after, then the cell can be interfaced through the panel. You see the little panel in the front part of the cell. You can start it, stop it, reset, and so on. And basically it will work by itself. So as soon as you start it through the panel or through the PLC outputs, it will grab the products when they come to the entry part, and then it will introduce them into the machine itself, and it will modify the parts. The thing is that these factory products, they are also kind of a smart products. So once they enter this machine, they can be converted to two different parts. I think this base on covers, or two different kind of products, and you can decide what you want to produce using the digital input and outputs. So we can check the component page, but there are some inputs in this component to decide if you want to produce one or the other. There is also an option to make the products to be you see the variable, the failure rate. You can decide if you want to produce how often you want the machine to fail. So it will go to error mode. You need to reset it. You can reset it from the panel or from using the ports. So it's kind of a machine with full features, but you don't need to program it. It's already working.
And like, for example, I see we can produce lids or bases.
Yeah.
Can the user program this machine to produce, let's say, something else? Is it possible?
Not as it is. So basically, what we have done is that this factory product, the product looks like a box, just a raw material. In the beginning, we have the blue and the green one. What we do when in this machine is that we change the visual aspect to leads or the base, and then you can play with them, the different products through your factory. If you would like to use this machine to do something else, you could, as you were mentioning in the beginning, you can just clone it. and use it. Yeah, you can clone this machine, you can clone the product, one of our products, and you could change the visual aspect very easily, just changing the geometries of the products, and use it to produce any other thing that you want.
So, for example, I can engrave some logo on it if somebody wants to show the product having a logo.
Yeah, I mean, you could do whatever you want. Yeah.
Okay. But this is not like the product is changed. So do we like...
No.
Okay, so we change the geometry of the product. That's what we do.
Yeah, and maybe we could show that in another course because you are developing these academic courses for the component builder. We are using some tricks inside the components, like the collision tag, to modify both the visual aspect, but you can modify also other aspects of a component using this tag. So basically, it's a way to communicate or modify a part in the component, and then use it in the behavior to change a color or change and modify the visibility of a geometry or whatever. So this collision tag, maybe it is a topic for a complete webinar, because we use it for many things. We use it for sensors, we use it for RFID technology, we use it for, in this case, for example, for changing the aspect of the how you call the product. So if you go to the base link in this, you see the data surface. This is what we use to interact with the component, and this is a two-way interaction. So you can both write a new value in the collision tag, or you can read it from another component. So you can use what we call the sensors in the components. The sensor object, which this one doesn't have the sensor object, but the machine in this case, the machine has a sensor object which actually can read the actual collision tag in the product, but also can write a new collision tag value. And that way, and that way you can do this kind of fancy stuff.
Interesting. I think we can do one more webinar and talking about how this can be done, change the visual expected. So it's like basically creating products in your simulated factory from raw material.
Yeah, I mean, I think if I'm not wrong, in this case, we have two or several visual geometries in the component, in the product itself, but we just make the visible the one we are interested in.
Got it.
Yeah. Okay. So it could be that in the beginning it's just a cube visual aspect, and then we have the two other options, and then we might change just the color depending the product. So we can play with all those variables to change the visibility, but the product is the same. So there are a lot of tricks you can do with the data model or in Simumatik to do this kind of fancy stuff. But as you say, maybe we can have a webinar about that.
This would be interesting. I would love to see how we can explore that. I think I saw one of our video where we were engraving Simumatik on the product. Was it the same way to do it?
Yeah, in that case, yeah. No, it's the same. But basically, in that one, I think the trick was that maybe the visual, the graving, what you are graving, that geometry is hidden inside another visual geometry. And what you do is just move it slowly using some parameter in the collision tag. So depending that parameter, it can start to maybe using an angle or whatever, moving it forward so it actually becomes visible.
Oh, that's very tricky.
Yeah, it's tricky, but again, it's so flexible what you can do with the geometries and so on from the behavior, so you can do this kind of fancy stuff.
Right. Yeah, a lot to explore in Simumatik. Okay, let's moving on to the next component. We have heavy-duty conveyor. We already saw that. We were using it in our system.
Yeah, those are the roller conveyors.
And similar way, we have
different sizes.
4 meter, 6 meter. Another one interesting is this portable robot factory, which we are still working on. So it's basically like a gantry again for pick and place.
Yeah, I think so. Well, it's going to be like a little.
Also on analog and digital both, where you can control that. And then we have a pusher. We have already seen it. This is already there. And then the stopper, which I was already using. But I believe we have some more components in pipeline besides these, which.
I think there will be more components coming. Again, we just wanted to do this experiment, create this component, check. Now we are coming to that soon, but see how our actual customers experiment with these components, see the different opportunities, and it's gonna be a base not just for us, but even for our users to build new components using this approach, simplify approach. And if they have some ideas, if someone has some ideas, you can write in the comments of this webinar. You can also send us some suggestions through using the chat or the feedback button in the app, or sending us an email to contact@simumatik.com or support@simumatik.com. So we will be very happy to read your comments or suggestions. So
yeah, that would be cool. I think we can also, we were discussing before to do a challenge. So maybe once our components are ready in our library, all the components are ready, we can maybe do a challenge where we can ask our users to create a factory with some process using those components, and the one who do the best or who's doing great will get a prize from Simumatik, something like that.
Yeah, I think we can have a Christmas challenge and promote it in the coming weeks, so we can just leave it open for creativity. This is the library. Throws as many components as you want in a system, connect them, program them with a PLC. We don't care, as we have been showing in other webinars. You can use any PLC platform as you want, and then just show us the result. We can just ask someone, the users, to record a video or GIF or something and publish it in our social media with a special tag, and that would be great. Yeah, I think we can do that.
This we can do, or it could be also starting of New Year. We can do if Christmas. We'll see which date is the best. But besides these components, are there other new components that we are creating? Not in the factory components, but in general.
In general, right now, I don't know. Actually, being honest, we are working all the time, but building components, but it's mainly for our industrial customers.
Okay.
So and what we have been focusing quite a lot the last weeks or even months is with frequency inverters and servo motors.
Okay.
So that is a topic we need to. Maybe it's good to mention it now because we know that many users ask us, okay, how do you do when you have frequency inverters or servo motors? How you use them with Simumatik? And we have a lot of experience with different platforms using, like for example, in Codices you can use simulated axis. In Beckhoff or TwinCAD you can virtualize the axis. In Siemens as well, you can use technological objects and simulate them. I think, and we have a lot of examples how we do with different platforms. It probably requires some course in the academy around this topic to show how we build, but we have built a lot of those components, both with and without feedback encoder. Let's call it encoder. So there are different options with this kind of components. You can just read the actual position from the PLC or the technological object or the axis in the PLC, and reproduce the movement in Simumatik, just open loop, we could say. Some platforms allow us even to send the feedback to the PLC, the actual position of the axis, and close the loop. Close the loop. That's the best solution, because then you can detect, your PLC could detect when the axis crashes or doesn't reach the position, or actually is gliding for whatever reason. So we have done a lot of projects with different kind of servo motors and so on, and that is something we are actively working, I can say.
Okay. So VFD and servo motors are the next use case we can achieve.
Yeah, I think we need to decide which will be the next webinar. Yeah.
Okay. And for example, when we are talking about PLCs and VFD, do we make a generic component, or do we specifically use VFD in the market and try to get the parameters?
It depends. That's the thing, that we have some generic components, but the problem is that frequency inverters and servo motors, they are by themselves a controller. I mean, there is a lot of technology. Inside there is a controller that takes care of all the parameters, the actual position, everything. So trying to embed all that in a component in Simumatik is quite complex with all the functionalities. So the best approach is always to try to use the virtualized version in the PLC, and use Simumatik just to move the axis, mechatronic axis in the model, and then give the feedback. So depending how this interface looks like, we may need to do modifications in these generic components that we have created. But I think the important thing for this, if we are having this webinar, the important thing is to show the general approach, how we do it, and then maybe we can show different specific approaches we have used, maybe for Siemens or Codices or whatever, or TwinCAD, and how different platforms may affect how we need to modify the behavior of these components.
I was asking because of the reason, like at the moment, conveyor, we can change the speed. We can do from 0 to 100% of the speed, which is kind of like VFD. But in general, when we use VFD, we also define acceleration time, deceleration time, mode of operation, 2-wire, 3-wire, and fault feedbacks. Do we try to make a controller like this, or do we include this in the conveyor?
In some cases, we do it in the frequency inverter component.
Okay.
So what I'm talking all the time is, we have a component that is,
Okay.
or several components that represent the axis or the servo motors or the frequency inverters. Those are components in Simumatik. In most of the cases, we try to put most of the behavior or use most of the behavior that we can get from the PLC when we can virtualize those elements or components.
Okay.
As we were telling now, in Siemens, you can use technological objects. And you can have them in simulation mode. So most of the computation of these axes and the parameters that you were mentioning, acceleration, speed, max speed, and so on, those are executed and controlled inside the PLC.
Right.
In the virtualized mode. Even in codices, you can do that. Almost all the PLC manufacturers have the virtualized or the simulated mode. So in that case, this makes the components in Simumatik simpler to use.
Okay. Yeah. But in some cases, when we use VFD, we don't use VLC. We just use a VFD and some electrical controls and just to control the pump. I think it would also be nice if you can use a VFD component just to use without.
We have that. We have those ones. So we have one. I think we have a VFD which just uses digital, which has just digital interface. So it doesn't connect to a PLC using a communication driver. Just some digital inputs and outputs, so you can run it. You can parameterize the acceleration and so on in the component, and then you can just start, stop, and change the maximum speed and so on with an analog, or the actual speed with an analog value, for example. And that is the closest you can. We have come to represent our VFD with just one component in Simumatik.
Okay. Oh, very nice. I'm curious to try that as well. I didn't try that as well. Still,
in this case, those factory components, they are not that complex. I mean, of course, they offer the opportunity to run them in analog. For example, the speed of the conveyor can be controlled with an analog output from the PLC. Yes, but it's not at the level of what we are talking with the VFD. I mean, will you just tell which is the nominal speed, and then you can run it 0 to 100% in the nominal speed using the analog value.
Right.
So not controlling the ramps.
But these components are more open for the students to just solve exercises which they might have in their classes. Do some.
I will say. I will say this approach can be interesting, definitely for education, because you don't need to. You could just put together as you did here. It probably didn't take you more than a few minutes to put together all these components. Of course, they are not connected to the PLC, but it wouldn't take more than 5 minutes to connect all the PLC outputs to different conveyors and add some sensors connected to the inputs, and then you have a base to start coding in any platform.
Right.
But we have some customers working with logistics that also want to have maybe this, not exactly this, but similar approach, because there may be a lot of conveyors. They know that the electrical configuration is nothing new. They do the same all the time. They have the same approach, and this works out of the box. The problem for them is the commissioning, because the systems may be big, different situations that need to be handled and so on. So for them, just having a simple interface between the model and the PLC is okay. So maybe it's enough. So maybe they can just, and even more important, if they don't use frequency inverter and they just use motor contactors, then definitely connecting the PLC outputs directly to the conveyors is saving time during the modeling and commissioning. So that's an option as well.
That's really nice. Okay, this was interesting. And what do you think we can do in the next webinar? Should we talk about this VFD or this machine production with the products? How we can create new products with the raw materials?
I think
this is very interesting. topic.
Yeah. I think both using the collision, how we use the collision tags, we use it a lot in industrial projects because many times we need to do tricks to simplify the process. It's not worth to do very advanced emulation, and we can use the collision tag to communicate between components and to modify some aspects of the components and so on. So I think we can have a more technical webinar and plan something with the collision tag. Alternatively, we could, I think one of the closest webinar, maybe the beginning of next year, will be also about frequency inverters and how servo motors and things, these kind of elements, to show how we control axis.
I think we did recently this for one of our industry project for Bosch Rexroth, not Rexroth, just the Bosch, and they had the SCADA robots. And kind of like move this with our technology object, if I'm not wrong. With the Siemens project, So this was already done, but we didn't publicize it. We have to make a public component which can be used IT as well. But maybe Daniel is working on that. We can make it in our second component as well as SCADA robots.
I mean, you can use it to control any kind of axis. In this case, what you're mentioning, we wanted to have a kind of to experiment a little bit. So we wanted to try the inverse kinematics functions. You have them in most of the PLC libraries in almost all platforms. So you can use inverse kinematics and then control servo motors in robot arms or SCADA robots or gantries or wherever. So maybe we can show two examples, one with a gantry, simple gantry, and another with the SCADA robot, and show how we do the model and how we do the connection through these servo components in Simumatik to the technological objects or virtual axis or wherever they are called in the PLC, to show how we close the loop and so on.
And I have one more question before we close the webinar. I noticed that you do a lot of workshops and training in the schools. So would you like to talk about what's the trend these days? What kind of technology students wants to learn, or teacher wants to teach their students? Which kind of systems they're using or components they're using? What is their teaching approach? Do you want to talk about that?
I think when it comes to education, I think still digital twins is a quite new topic. So in these workshops, it can be like guest lectures or workshops. We're talking more about the background for this technology, why it's so important that we start using emulation, this kind of digital twins to help industry to work more efficiently. I think that awareness aspect is super important. So both teachers and students understand that this technology is already here and it has several applications, because usually in these workshops, I don't just talk about virtual commissioning. I mean, building these kind of models to do the testing. We are talking a lot about supporting the entire life cycle of the systems. Everything from helping to make a good design, supporting engineers during the development of the PLC robot programs, not just the commissioning, but also you as you have been doing PLC programming and robot programming, you know how good it is, how easy it is to program against a virtual model instead of having the real one. Because clicking reset button and starting from zero without needing to move a pallet with a truck and so on, that makes everything easier to work. So having the model from the very beginning as engineer or programmer is a big advantage. And then later, when you do the FIT test, maybe virtually, we call it virtual FIT. That's also something we start to discuss quite a lot. And once the model has been verified, validated, is working properly with the PLC and robot code, training operators. This is another topic that is kind of interesting. Using the models later, once the system is in production, to support updates, adding more variants or more products to an existing system, without affecting the actual production. This is something that when we have workshops with industry on big factories, showing them the opportunity that using the digital twin, they can experiment and prepare the existing system to produce maybe a new variant or a new product without affecting the production until they are confident that the changes in the program may work and so on. If they need to teach the robot new targets and so on, they test everything, then they can do the modification just a weekend without requiring to stop the production longer. So it's more about the awareness, showing that there are a lot of useful applications around this technology. So engineers, both in the educational area or in the industry, they understand that maybe they have to start playing with this. So we don't use very advanced systems to show the options. Just do simple exercise so the engineers understand that it's possible. It's not rocket science. It's easy to use, and then they kind of understand. Oh shit, I can do this.
I think this is also an industry they can use to train their engineer, how the system is working, how the PLC program is affecting, for example, conveyor, how the sensor signal is coming to PLC, and how PLC solve the logic. So for training purpose can also be used a lot.
Yeah.
Great.
Yeah. Then as we did with the project you mentioned, with the last one we published in LinkedIn for the fair with Bosch, it was a simple factory, but in that case they just wanted to have a running factory, of course controlled with the PLC and so on, but it was more to demonstrate the capabilities of other layers in the factory that gather data, show data in dashboards. You can do big data, you can do data analysis, you can do AI on top of that, and so on. So having these kind of models running, controlled by a PLC, allows you also a safe environment to test other technologies that are above the PLC without requiring energy, without requiring raw material production, and so on.
Exactly.
Yeah, it's way more sustainable. All the testing, or even in this case, there was demonstrating that technology.
Yeah,
you can use it for that.
That's a very
and another application. That's very nice. And another kind of use that we are seeing is that instead of using Simumatik for doing emulation models, just use it for monitoring existing system.
Right.
And we can do it. It's just, of course, it's a simpler model, but instead of behaving like the real one and having something in parallel to the real thing, what the model does is just showing what's happening in the real machine. So it's just gathering data from the PLC or whatever controller you are using and just visualizing it. Yeah. So it's like a rich SCADA, we could say.
Yeah, true. I also did lately a project with this virtual lab, and I was calculating OEE in my PLC and showing it on the dashboard. So it's also quite realistic to show OEE data using this factory simulation. It was also very interesting to work on. And any new features that are coming up in the platform or in the workspace?
Yeah, there are new features coming for the 2D drawings.
What is in 2D drawing?
Yeah, for the 2D drawing, we are adding the flip. So instead of rotating just the symbols, flipping, and a lot of bug fixes in that. Then we are doing a lot of optimizations, both in the workspace and the app side. I guess the users have seen that the loading time has improved a lot. Right. So now the systems are loaded quite quicker. Even how we handle the geometry and so on, it's been improved. We are still working, as we mentioned in the last webinar, with the synthetic cameras or vision to allow vision systems. That's in the pipeline, and we are working on that. A lot of new features to the undo and redo buttons are coming very soon. So that is already in testing. Yeah, we have it already in testing. We have save as exporting and importing systems to XML. That's also a really cool feature. Yeah. So maybe maybe all these features or some of the features could be mentioned once they are live or in production. We can mention them in the next webinars as well. Yeah.
And I heard about something you're doing with virtual reality. You said there is a requirement from a school or from the company. I'm not sure. So what can we do with virtual reality? What is the...
Yeah, in virtual reality, we are doing this. You can jump inside the model.
Okay.
If you have a virtual reality goggles, and then you can interact, grab stuff, and so on. It's still in beta, but the idea is to now with the last improvements, hopefully we have better experience. So we hope that people tries it. Uses, if you have access to VR equipment, you can just connect it to the computer, and you will see a new icon appearing in the top bar in the toolbox, and if you just click it, you just enter the model from the VR. So you don't need to install anything. It's just if it's compatible, it will detect, the web browser will detect it, and you will just jump.
So I just have to open the browser in my virtual reality and get inside the special icon which you mentioned, and then I'm in the virtual system.
Yeah, depending the hardware. Yeah, sometimes you have the browser inside the virtual reality equipment. Sometimes the virtual reality goggles need to be connected to the computer. But anyway, you just access the Simumatik app. If it detects that you have virtual reality goggles connected, it will show the icon, and then you can just experiment.
I think this is also we should show in the webinar, on one of the webinar next
year.
And can it be like, just curious to know, can it be like a teacher goes inside this virtual reality and the students also joins, and then they're talking about it? Is it possible multiple users?
Yeah, I mean, as always, Simumatik, when you work with the online workspace, and soon as well with the local workspace, you will be able to be several people connected.
Okay.
Or you are able to be several users connected to the same model or the same workspace.
Okay.
So if you have access to Google's, you can actually several people access to the same.
Do they talk within the system, or is it an external way they have to communicate?
No, we don't have audio. We don't have audio voice features. But I mean, if you have any voice streaming, you can use a Steam, Discord, or whatever, and you could interact there. You can see each other.
Interesting. All right. So a lot of new things are coming. I think 2024 will be full with tasks.
Yeah, it will be.
Gonna be busy. But I think that's all we have covered so far. We have covered almost everything about the components. And as soon as the new components are ready, we will make a post on LinkedIn, and you can be active and have a look there. If the component is ready, you can go around and play with that. So that was all for today. And feel free to
we can say. Yeah, well, no, I was thinking that we can say Merry Christmas and Happy New Year to everyone.
Happy New Year. And feel free to come back to us for any other query. And I hope you enjoy your Christmas, your New Year. New Year is going to be great for us with a lot of new features and a lot of new things, new courses and new tutorials.
And if someone wants to start playing around with these components, go ahead. They can start building, and as soon as possible, we will define this challenge and publish it in our social media.
That we will do that, 100%. Okay.
Great. But thank you. Yeah, thank you, Raj.
Thank you for joining, and see you.